Hello, today we're going to look at ratios, rates, and proportions. We'll start with ratios. Ratios are comparisons between two or more things, and those things have the same units. We can write ratios in three different ways. The first way is a fraction, and a fraction only makes sense when we are comparing exactly two things. So as soon as we have a third thing, we don't want to use a fraction anymore. But a fraction looks like 2 over 3. We can also use the word 2. So the fraction 2 over 3 is equivalent to the words 2 to 3. And then we can also use a colon. So 2 colon 3. All of these ways are read as 2 to 3. And with the 2 and the colon, I can have more than two things that I'm comparing. So I could do 2 to 3, to 5, or 2 to 3, to 5, to 7, to 12, to 2. I can go on, and I can compare, 20 different things if I wanted to. And I just keep doing a colon and then another number, colon, another number. But let's do some examples. So suppose we have 4 blue poker chips, 3 red poker chips, and 2 blue poker chips. 2 white poker chips, sorry. Find the following ratios. Blue to red. So I look at how many poker chips are blue, how many poker chips are red. And I get the ratio 4 to 3. So again, I can do it with a colon, I can do it with a fraction, or I can do it with the word 2, and they're all going to be the same. What about red to blue? So the ratio blue to red is very different from the ratio red to blue. So you have to make sure that you're doing it in the correct order. Red to blue would be 3 to 4. What about white to total? We're going to be doing this a lot in the later lessons in this quarter. We're going to be looking at the ratios of something to the total. So in order to find the total, I need to add them up all together. I've got 4 blue plus 3 red plus 2 white. That's 9 poker chips in total. So the ratio of white to total is 2 to 9. We can also look at white to blue. There are 2 white poker chips, there are 4 blue poker chips. So this is the ratio 2 to 4. If I had written it as a fraction, I'd have 2 divided by 4, which hopefully we can all see could be simplified down to 1 over 2. And I can do the same thing with the ratio. 2 to 4 becomes 1 to 2. We always want to reduce. Just like I always want to reduce fractions, I always want to reduce ratios. As soon as my numbers all have something in common, I want to get rid of it. So here's an example of more than two things that I'm comparing. So blue to red to white. So again, just make sure you're doing it in the correct order. You have 4 blue, 3 red, 2 white. So 4 to 3 to 2. If I wanted to reduce this ratio, I would have to find a number that all 3 have in common. The 4 and the 2 have a 2 in common, but there's no 2 in the 3, so I cannot reduce this one any further. So it's just 4 to 3 to 2. When dealing with business ratios, which means money, we usually reduce the ratio so that the second number is a 1, and this is called a unit ratio. So for an example, net profits this year were $3,500,000 compared to $2,750,000 last year. Write the ratio of this year's profit to last year's. So I'm going to start off as a fraction, so I want this year's to last year's, which is 3.5 million divided by 2.75 million. I will do out the division, and I get 1.27 repeating divided by 1. And this means that $1.27 was made this year for every dollar that was made last year. So it makes more sense, it's easier to comprehend comparing something to 1 than it is comparing it to another non-1 number. So that's why we tend to use, again, what's called a unit ratio. So for every dollar last year, we made $1.27 this year. Remember that when we comes to terms with money, we have 2 decimals. So even though it's 1.27272727, we round to 2 decimals in this case. So next we're going to talk about rates. A rate is also a comparison amongst two or more things, but the difference is that they have different units. And generally, instead of saying the word to, we say the word per. So we look at things like miles per gallon, miles per hour, earned runs per 9 innings, etc. So we'll do a couple examples. Carl can travel 400 miles on 16 gallons of gas. Find his rate of miles per gallon. So miles per gallon means miles goes on top, gallons goes on the bottom. And I can simplify that to 25 miles per gallon. It's a really nice integer here. So let's try another one. Carl can travel 213 miles in 6 hours. Find his rate of miles per hour. So again, we'll put the miles on top, the hours on the bottom. And then if I simplify the fraction, I get 71 over 2 miles per hour. But notice this is the same thing as 71 miles per 2 hours. But if you ask someone how fast are you going and they say 71 miles per 2 hours, you'd probably look at them a little funny. So a lot of these rates we're also going to write as a unit rate. So we do out the division. And we get 35.5 miles per 1 hour, or miles per hour. Okay, so we'll typically see these as unit rates, something per one of something. So as another example, Sandy read 12 books in 5 months. Find her rate of books per month. So I want the books on top, the months on the bottom, so 12 over 5. And again, I can change that to 2.4 books per month. Find Sandy's ratio, that should be rate, of months per book. So months per book, I flip it, I have the 5 months on top, the 12 books on the bottom. And if I do out that division, I get 0.416 repeating months per book. So again, the order really matters. Books per month, months per book, the numbers are very different. So just keep that in mind. Another example, which of the following is a better price? We have something that is brand A costs $3.81 per 12 ounces, and brand B costs $4.80 per 15 ounces. So if I just look at it and say, well, one's $3.81 and one's $4.80, obviously the $3.81 is going to be the better price. But then you have to look at what it is actually getting you. The $3.81 is only getting you 12 ounces. The $4.80 is giving you 15 ounces. So how do I determine which one is a better price? Well, we want to compare their unit prices. How much is it per 1 ounce of both of the brands? So for brand A, we have $3.81 per 12 ounces, which gives us $0.3175 per ounce. Brand B, on the other hand, is $4.80 per 15 ounces, and if I do out that division, I get $0.32 per ounce. Which one's better? Well, brand A is better. It's a little bit cheaper per ounce. Okay, so using unit rates is really good when you're comparing things. Okay, and then to end the section, we're going to look at proportions. A proportion is when you have an equation that's a fraction equal to a fraction. So something like A over B equals C over D. We're usually given 3 of the values and looking for the 4th. And if that's the case, there are 2 different types that we can have. The first type is when the unknown is in the numerator. So for example, x over 4 equals 3 over 8. In order to solve this, I want to just use the multiplication rule of equality and multiply both sides by my denominator. So in this case, I'm going to multiply both sides by 4 and get that x equals 3 over 8 times 4, which is 3 over 2. Don't try to do anything more complicated than that. I have x divided by something equals something, so just multiply both sides by your denominator. It's the quickest way to go. The second type is when the unknown is in the denominator. So for example, 4 over x equals 3 over 8. There are typically two ways that we can do this. The first is to just take the reciprocal of both sides. So 4 over x equals 3 over 8, then x over 4 equals 8 over 3. And then just like before, I'll multiply both sides by 4, and I'll get 32 over 3. The other method is called cross multiplication. And I'm going to take my x times 3 and equate it to 4 times 8. So I create a little cross, which is why it's called cross multiplication, and then just put them both on the other sides of the equal sign. So again, 3 times x equals 4 times 8, which is the 32. To get x by itself, I'll divide, and I get x equals 32 over 3. So either method is perfectly fine. You should get the same answer in either case. So let's try some examples. So 0.5 cups of flour are needed in a recipe for 5 servings of some dish. How much flour would you need for 8 servings? So this is something that happens to me a lot. I like to cook, I like to bake, so I need to modify my recipes depending on how much I want. So what I'm going to do is I'm going to set up my equation. And the thing to remember when setting up your equation is that things actually have to be equal. And that includes your units. So if I'm setting it up, I'm comparing my first sentence, the 0.5 cups, to the 5 servings. And then my other equation also has to be cups over servings. So I'm looking for the cups, so I'm going to call that x. So 0.5 over 5 equals x over 8. Make sure your units match up. Cups and cups, servings and servings. Once I have that, I'll rewrite it, getting rid of the units to make it a little nicer. 0.5 over 5 equals x over 8. So to get x by itself, I'm going to multiply both sides by 8. And I get 4/5 cups of flours. As another example, a printer can print 40 pages in 3 minutes. At this rate, how many pages can it print in 1 hour? So again, I'm going to set up my first rate as 40 pages per 3 minutes. And then I have x pages per 1 hour. So 40 over 3 equals almost x over 1. The problem here is that I've got minutes and hours, and those are not equal. A minute is not equal to an hour. So I have to do a little bit of math here. I can either change my 3 minutes into hours, or I can change my hour into minutes. And I think most people would prefer to change 1 hour into 60 minutes. So I'm going to get rid of this middle guy and look at 40 pages per 3 minutes equals x pages per 60 minutes. Again, I'll rewrite it, getting rid of the units now that I know they match. Multiply both sides by 60, and I get 800 pages. If I had left it as 40 over 3 equals x over 1, my answer wouldn't make sense. I would have made less pages in an hour than I could have made in 3 minutes. So you want to make sure your answer makes sense. Does 40 pages in 3 minutes make sense to correspond to 800 pages in 60 minutes? Okay, so always, always, always make sure that your answer makes sense. And as another example, I think our last example, Mark read 3 books in 5 months. Question A, at this rate, how many books could he read in 1.5 years? So I'm going to set it up. I've got the 3 books in the 5 months, and I've got the X books in 1.5 years. But again, I don't want years, I want months. So 1.5 years is 18 months. Right? There are 12 months in 1 year, 6 months in half a year, so that's 18 months. If I want to get x by itself, I'm going to multiply both sides by 18, and then just do out that math, and I get 10.8 books. Question B, how long would it take him to read 20 books? So here I'm going to flip the equation that I had before because I always want what I'm looking for on top because that equation is easier to solve. So before I had the 3 books over 5 months, but now I'm looking for the months, so I'm doing 5 months over 3 books. So I flipped it because I'm looking for time now. So x is the time. I'm going to put the time on top. So 5 over 3 equals x over 20. The books is on the bottom. Again, I'll just multiply both sides by 20. And then that is 33 1/3 months. Right? This was months, so x is in months. Okay, so again, just be really careful with your units. And that's really it. So read over the book, try out some of the homework, and let me know if you have any questions. Good luck.